Hi everyone. In this video, we are going to study basic rules of probability. The first one is multiplication rule and the second is addition rule. Let's begin with multiplication rule. According to multiplication rule, if A and B are two events defined on a sample space, and if A and B are independent, then the probability of A and B equals P of A times P of B. Let us have an example. In drawing two cards in succession in a deck of cards, find the probability that these cards are both aces, given that, letter A, first card is replaced back. Letter B, the first card is not replaced. First, let us write our formula here. The P of A and B equals P of A times P of B. Let us begin by solving problem A. We may write here the P of A's and A's equals P of A's times P of A's. But in letter A, the first card is replaced back after drawing. So when we take the probability of the first ace, we write 4 over 52. There are 4 aces out of 52 total sample space. And when we simplify, this is equal to 1 over 13. Let us take the probability of the second ace. And this is P of A's equals, again, this is 4 over 52. Remember, we replaced back the card, and when we do that, there is still a total of 4 aces. And then, there will be a total of 52 sample space. And when we simplify this 4 over 52, it will be 1 over 13 also. Now, using our formula here, let us now substitute the values. So this is equal to 1 over 13 times 1 over 13. And the product is 1 over 169. We know that we multiply numerator by numerator, and that is 1 times 1 is 1. Multiply denominator by denominator, 13 times 13, and that is 169. So the probability is 1 over 169. And this answer we will write below problem A. Let us now solve for problem B. This time, the first card is not replaced. Taking now the probability of the ace on the first draw, we will have 4 over 52. We know there are 4 aces over 52 sample space. So let us simplify this into 1 over 13. For the second ace, since we are not replacing back the first card, we will have 3 over 51. We assume that 1 ace is taken in the first draw, so there will be 3 aces left in the deck of cards. And in the denominator, it will be 51. So that is 52 minus 1. We subtract the first card that we draw in the first event. So the probability of the second ace is 3 over 51. And when we simplify this, we will have 1 over 17. So let us substitute these values in our formula here. So we have 1 over 13, that is for the first ace, times 1 over 17 for the probability of the second ace. And the product is 1 over 221. And this answer we will write below letter B problem. We were able to write the answers for our example, and we are done with this. Let us go now to addition rule. According to addition rule, if A and B are defined on a sample space, then the probability of A or B equals the probability of A, this is P of A, plus the probability of B, we can see that this is P of B, minus the probability of A and B. Now, if A and B are mutually exclusive, it means there is no common with the A and B. Thus, the probability of A and B is 0. In our formula here, this portion here becomes 0. Thus, the formula will be simplified into this. The P of A or B equals P of A plus P of B. Let us have an example. In a deck of cards, find the probability of drawing letter A, king or an ace. Letter B, a heart or a face card. Let's start with our problem A. Let us write our formula here. The P of A or B equals P of A plus P of B minus P of A and B. But drawing a king or an ace is a mutually exclusive event. It means the formula will be simplified into like this. P of A or B equals P of A plus P of B. It means to say, we can write now that this P, A or B is now P of king or ace. And this is equal to the P or probability of king plus P of ace, the probability of ace. So we write 4 over 52 for the P of king. We know there are 4 king cards in a deck of cards. Plus the P of ace, we write also 4 over 52. There are 4 aces in a deck of cards. And then, when we simplify, we can see that the denominators are the same. So we can operate the numerators. 4 plus 4 will be 8 over the same denominator, 52. And when we simplify this, it is now equal to 2 over 13. We divide the numerator and denominator by 4. And this value, 2 over 13, we will write in here. So the probability of a king or an ace equals 2 over 13. Let's go now to problem B. Let us take the probability of drawing a heart or a face card. This is not a mutually exclusive event. So we may write now, using our formula here, that this is P of heart or face equals P of heart plus P of face minus P of heart and face. So let's begin with the probability of heart. There are 13 cards with hearts. So that is 13 over 52 plus the P of face. You can see here there are 12 face cards in a deck of cards. That's why this is 12 over 52. Then minus the P of heart and face. There are 3 cards here, heart and a face at the same time. So we see here 3 over 52. Then let us simplify the fractions. We can see that the denominators are the same. So we can write the numerators 13 plus 12 minus 3 all over the same denominator 52. When we simplify the numerator, it will be 22 over 52, which is reduced to lowest term as 11 over 26. And this value is our probability of drawing a heart or a face card. And we put our answer below problem B. We are done with our example here. This is our final answer. I hope you learned something from this video. See you again next time.